Hey guys, and welcome back to this class, Artificial Intelligence, Reinforcement Learning in Python. In this lecture, I'm going to give you tips on how to navigate this course and how to maximize your returns. Like other online courses, you don't have exams or grades, so you really have to be the kind of person that takes initiative and is proactive about learning. That means understanding all the equations that get written down, and if there's a derivation, making sure you understand each step, and being able to do the derivation independently. That means writing all the code yourself, and trying to do that before watching me code. You should consider my code to be the answer to the problem, not something you just sit and watch straight through. People that have taken my other courses understand this, but from time to time I see students get confused about exactly how to practice. Most importantly, it means asking questions when you need help. Sometimes people are afraid to ask because they think their question is stupid. I've seen a lot of crappy reasons for why people can't ask questions. In reality, it's free and there's nothing stopping you. Machine learning isn't like taking a physics course. There aren't 20 practice problems at the end of the chapter for you to do. The nice thing about machine learning is that it automatically self-checks. Either the code you wrote runs or it doesn't. If it runs, that's a good first step. Either it behaves as expected or it doesn't. If it does behave as expected, that means what you wrote is good and it's working. Debugging is a part of programming. You should be a good debugger and not give up the instant your code throws an error. It's all part of the process. People think they should be able to do something in an hour when in reality it should take an intelligent person all night or maybe even days. So keep that in mind. Everything we do automatically self-checks. Either the code you write works or it doesn't. Strive to make it work on your own. Remember that the code in the GitHub repo has already been verified to work, so check your work against that. It's even possible for your code to be better than mine. You absolutely must write the code and do as much of it on your own as you can, ideally working off of the pseudocode from the theory lectures only. The difference between this and my other machine learning courses is that it's going to feel like we're doing the same thing over and over again. This is opposed to, say, in my supervised machine learning class where you learn the decision tree, naive Bayes, k-nearest neighbor, and the perceptron. Those were 4 distinct algorithms. In this course, all the algorithms look alike, so the real challenge is going to be telling them apart. Understanding the differences between each method and their advantages and disadvantages is the key to this course. You've heard me say in previous courses that all data is the same. I think it's pretty easy to achieve this level of perspective in machine learning. When we talk about supervised learning and unsupervised learning, we always deal with the inputs X and the targets Y. We don't need to specify what X is or what Y is, and you still understand what I'm talking about. You already know that X can represent any feature. That could be age, weight, height, number of pages visited in your e-commerce store, a DNA sequence, and so on. Supervised and unsupervised learning works for all different fields: finance, biology, online advertising, and more. We don't need to specify what we're talking about. Saying X and Y is good enough because the same algorithms work no matter what the data represents. So we say all data is the same. The question you might have is, does this apply to reinforcement learning as well? I think the answer is that eventually it will, but it probably won't at first. Reinforcement learning is more difficult because the interface to the agent is much more broad than just features and targets or X's and Y's. However, once you get used to the idea of taking an environment and thinking about how you can encode states, actions, and rewards, you'll get better and better at abstracting these concepts. So in the future, you won't need to think in terms of specific problems like tic-tac-toe. You'll instead think in terms of abstract entities like states, actions, and rewards, and that instinct will become more automatic over time. In deep learning especially, experience has shown me that a lot of people want to jump into deep learning because it's popular at the moment, but they have no idea what the prerequisites are, and so they don't know what they don't know. I think I've done a good job of outlining those prerequisites because nowadays, the number of messages I get saying it's too hard or it's too much math, or why am I not learning how to build self-driving cars has decreased to almost zero, which is great. So with reinforcement learning especially, this is a big jump. My goal is two things. Number one, you end this course knowing what you don't know. And number two, knowing what you need to know in order to know the things you want to know. So perhaps your goal is to build an AI that can play Super Mario. This course is going to fill in the gaps, not all the way to that point, but very close. If you think you'll be programming an AI for Super Mario tomorrow, then you are currently in a state of you don't know what you don't know. But by the end of this course, number one and number two will be true.